Okay.
You will have displacement over force and real-time values
Hello, everyone. Some of you were here yesterday as well, or you guys are all new faces? Okay, good. Well, welcome to the lab. And so today we will break 3 specimens. 2 are the ones that you guys prepared about a month or so ago, and the one will be from the other group. And it was because I wanted to show them a balanced failure, and you guys will see a over-reinforced failure potentially. Yesterday, we were able to show the flexural failure, but the balanced failure, unfortunately, it failed in shear because of the lack of stirrups. So it could happen today as well, but we will see. The goal is to show you the first specimen where there is no reinforcement, so you can estimate the models of rupture. We studied that, right? The only departure for this specimen is the ASTM standards. They require to load this beam so that this distance, and this distance, they are essentially the same, L by 3, L by 3, L by 3. And even it is also advisable that this dimension is more or less the same as that dimension, but it's not the case. Not a big deal because we are not doing any research work. The idea is to show you how the experiment works and to still estimate the flexural models of rupture for this beam. Yesterday we were successful and it did fail right in the middle. So we are hoping it happens again today as well, okay? So you can make that note in your lab report that that's the departure. And the reason we did this is because we have this plate on the top which is not very strong. Last year we followed the code, and for one of the beams, the over-reinforced beam, we broke the top plate essentially, and we don't want to do that again. Okay, so the breaking should not take too long, about an hour or so, give or take, and you will see the various modes of failure. So the first one will be strictly a flexural failure. It should just fail right in the middle. The one where we have 2 longitudinal rebars, this should be a failure in flexural. It's a tension governed failure, assuming it won't fail in shear. It happened yesterday with one of the specimens. And then the last one is over reinforcement, and you should see concrete should fail before steel yields. Okay. So I will make some, please make sure you all have glasses. Yesterday I received an email from the chairman. Apparently he was looking at, checking out our live feed, and he said, "You are the only one without glasses." And so that was a bit embarrassing, eh?
You can squeeze in a bit further, yeah. There is more space here, somebody wants to come out.
Okay, so where is the marker? I just want to take some measurements, eh? Thank you.
Yeah, make some more space out. There's a bit more space there, there is space here. Yeah.
Okay, guys, so I think
It's always been working.
where is our Bastion? Measure tape. The measure tape was somewhere here.
Yeah, find yourself some more space inside. It's a bit more around the corner, taking more space out here.
Armando, where is the measure tape? I'm looking for a measure tape.
That one that was here, that was
No small one?
maybe it's on the table here. Baskin, the measuring tape we used yesterday, you know where that went? On the table, maybe outside?
Oh, fine, thank you.
So I'll tell again, everybody, welcome here. Should be fine. Couple of things. Okay, so you can view also what's happening here. Real time, the review, showing the deck side of it. Okay. And here shows the instrumentation. So everything that is going on that computer is showing here. This is on Zoom and Bastin is just showing the link so you can have it on your phone. This is on our stream on UviCive, our YouTube channel, so you can also look at that. This is all recorded, so you can also get a copy tonight or tomorrow to be uploaded. You also being recorded up here. This is just on a time lapse, just for fun, for memory of what's happening today. And that would be shared.
So this is moving still.
Sorry?
34.
So the first specimen is a control sample of reporting, right? So we'll be running slower because it will be snapped pretty quickly at a lower capacity, and there will be crystalline of reflection with it. So this will be running at 0.8 millimeters a minute, and the other test will be running about 3 millimeters a minute. So it's a displacement control, not force control. So the machine will move at this set rate. You'll see at the beginning when we first start running the test, the window will pop up and will ask for what frequency you want to go for, and the battery will enter 0.8 for this test.
Okay, guys. So, yeah, I would take these measurements because you guys will need them for the lab report. Other than that, let's start. Okay? Okay, let's do this. And as Armando was telling, this is a displacement-based test, which means we are controlling the displacement as opposed to the force. So your displacement, because we are controlling the displacement, it will be along the x-axis. It becomes your variable, and the time will be in the vertical direction. And you'll see that force displacement curve on the screen. So vertically it is force and horizontal is displacement, right?
Yeah.
Yeah, okay.
So as you can see right now on the data, it's moving very slowly, and you have those rubber pads. So it's just noise. You're not really showing anything. As soon as that starts loading, and then we start putting it play, as you can see now. So, and
Yeah, this jaggedness will disappear
The bounce, right?
soon. Yeah.
The little pads here are for distributing the load uniformly, right? Obviously because the surface is not perfect on your sample to avoid stress concentrations.
Yeah, and you can see how this jaggedness is disappearing slowly, and eventually you'll see it's going to be a pretty smooth line.
What's this device called? Machine?
I think this is some kind of a universal testing machine, right?
Yeah, the general name is a universal testing machine.
Yeah.
Brand is MPS. Got a big logo, but it's the same as that one there, MPS.
Yeah. What is the capacity of this?
This is 250 kilonewtons, and that one is 2 million newtons. So that's about 10 times the capacity of this. This one has the benefit that you can do dynamic loading, and we use this all the time for that kind of testing. Like for instance, all those wood panels you see in the back there, they are connected with joints, and they are dynamically loaded here like it's simulating earthquakes. And look how the joints fail. That machine is obviously much higher capacity, but that's only does semi-static loading. You cannot do dynamic loading. The hydraulic unit is this large machine in the back with a black box. Has a lot of oil capacity of pumping it because it needs to be moving fast. Okay? Connected to the same system, you have that manifold that connects to that large hydraulic unit in the back. You can see there is a big actuator in the back that has a half million units capacity. And we'll be installing it for measuring out, for instance, the entire wood panel
Are
like
we
on the wall of a
sharing
house
this on,
and shake them.
Hold on, I have to check if it is.
This thing up here, it's a chamber that can be rolled into position right inside the machine as a bore on the top and the bottom, so that the hydraulic system can move in and you can do a test in a controlled environment. The temperature can be several hundred degrees to minus 50 or even colder. So if you're testing especially steel, the properties may change and still be at what temperature you're testing it at.
Oh, so you already uploaded to Brightspace then, the link.
The link is on Brightspace.
On
I
Brightspace.
sent it
Yeah, you just did it
as
to save
an-
your time.
I sent it to an anonymous.
This is just a live stream.
Yeah.
It's
So that's
just-
that's it. Yeah. For
Awesome.
the live stream, they just need to go. On the
They just
YouTube
know to.
channel.
Okay, great. That's
They just
awesome.
Go on the YouTube channel.
No, this
Did
is
you
good.
mention about the YouTube channel?
I didn't,
Okay.
because I don't have the link.
Well, just to say what is our like.
Is it the same?
YouTube
Is it the same link from
yeah,
yesterday?
it's not an actual link.
The yesterday you gave me,
No,
I
it's
put
not
it on
the same link because
Brightspace.
it's the same. It's a different video.
It's a
But
different.
it's the same.
Did you send it to me? Like the one you sent me yesterday?
I can send.
Yeah, if you sent it to me,
But if they know the channel, they just go to the channel and they go to the live streaming and it shows. But anyway, it's just easier that way. But let me.
yeah, if you send it to me, I can post it. Yeah, what was the? So now you guys can see how smooth the loading load displacement curve is. And if you guys have any questions about the lab report, now is the time. I won't be able to answer any questions during the lecture. It's just that I have a lot to finish. And potentially you guys will have questions about midterms as well. So we only have 4 lectures, and I have to wind things up now. Yes?
So will the data from both days of testing be compiled and posted on Brightspace?
That is correct, yes. Yes, and when you say compiled, it just means you'll have files showing force in one column, displacement in the other column, and probably there will be a third column with time.
So these will be like Excel files?
Excel files, yes. And it will be your responsibility to process the data and make sense of it.
So the report should have the graphs, the calculations?
I will send, what I'll do is I will post my lecture slides from last year
Okay.
on Brightspace, so you can see what I am expecting from you.
Okay. And last year, how many pages were the reports roughly?
Well, as for the report, there is no limit on the number of pages. I'm not expecting you to write a thesis, but then at the same time, I'm not expecting you to just show the graphs. Basically, the goal is to state what your objective is for the lab report, the material that was used, what was done, and then basically the results. Oh, there you go. Yeah,
There is a bit of a lag on the video, so you'll watch it again.
there we go. So so yeah, again, this is a success story, as you can see. That's what we were expecting, and it did break right in the middle.
Are we reporting on all 6 samples?
Yes, exactly. Yeah. So the graphs from last year will show what I am looking for. Unfortunately, you won't have, at least for one specimen, the balanced failure won't show a balanced failure. It will be a shear failure. So, but you can report that. It's just whatever you observe, you put it on the report, right?
But the report is pretty similar to like other university reports.
Absolutely, yes. I'm not asking for anything unusual here.
Okay.
Yeah.
And it's 2 weeks from today?
Yeah, exactly. I would say so. 2 weeks from today would be a good time frame.
I'm going to send you guys a link.
And you want to get it out of the way before your final exam as well, right? Yes. And this one has no air entraining agent, right? This one has control specimen, no rebars, and no air entraining agent. And which one has the air entraining agent? Group 1, no, not that one. I can't even tell, can I?
This one
Yeah,
here
no.
says,
Yeah, no air entraining agent.
and this one at the bottom says air and training.
That is correct. And if you look at this, the surface of this and the surface of that, you should see lots of little micro, lot of pores here.
Yeah.
In this, in fact, you could see the surface here because all our specimens, they have air entraining agent with the exception of this. And the surface, this surface should be different from that. So if you look at this, you should not see the same pores as you see here. There are lots of microscopic pores in this, which help with freeze and thaw essentially. And that's the purpose of air entraining agent as we discussed in the class. Night.
So when you're analyzing bridges to determine if oversized loads can go on it, did older bridges not have air and training agent when they were built?
That would be true, yes,
Okay.
exactly. And that's why we run into durability problems with those.
So is that a big issue with a lot of bridges in the province, or?
Lots of bridges, yes. Leaking joints, leaking bridges, and yeah, exactly.
And what do you mean by leaking bridges?
Well, leaking bridges mean that there is a drainage system on the bridges.
Okay.
And what happens is once the drainage system stops working, because you don't necessarily have the ability to go and clean those bridges regularly, drains get clogged,
Okay.
and then the water starts flowing over the bridge, and then eventually, things go wrong, and slowly and gradually steel is exposed, and once corrosion starts, really, that's when things get really messy.
Okay.
Yeah, and then concrete spalls, and over time you see these girders with a lot of corrosion stains on them.
Yeah.
And I think I have shown one of the pictures in the class as well. Yeah, and we have lots of those, and that's why province is always busy. They try to replace those bridges, a few of them every year.
So is there a list of bridges where it's like they're critical to be replaced soon?
Exactly. And again, when they say critical, not from a strength point of view, but from a durability point of view. So there are two components to it. One is durability, one is strength. When it is the strength is compromised, we load post the bridge. We say loads cannot go over this bridge. But general legal loading is still okay. But then there are cases where we don't even allow legal loading. And those bridges definitely become a priority for the province to replace. But sometimes those bridges are so remotely located that really they don't see a lot of traffic. So they just stay load posted for many years before they get replaced.
Okay.
Yeah. Okay, so this is the two bars. So we have two rebars. I don't think you guys prepared a specimen with which has two longitudinal rebars. So this should be potentially a tension controlled failure where we should see lots of cracking down below here in this region, not here. And we should also see lots of warning before this beam fails. Okay. We'll see how it goes. I hope that this fails in tension and that fails in shear, so you can see the difference between the two.
Does this have air and training agent?
Yes, all your specimens have air and training agent except one controlled specimen, the one we just tested.
Is that one? It says
Oh.
no
I don't know why they did that. I think I was pretty clear on that. This year I was not involved with the lab, and I think, I'm surprised. AEA, I don't see why would they not have air and training agent in those.
They might have just mislabeled it.
I think so.
So
Yeah.
are we ready to run?
Yes, please. So let's go with the assumption that it has, but once we break it, we will know because we can compare the surface with this and we'll find out. Like this one clearly shows that there are lots of pores here. You can see them. They are microscopic, but if you compare the surface of the two, you really have to look at it, take a closer look.
Do you think there'll be an issue that this beam isn't very consolidated at certain spots?
Well, that's the other thing I wanted to. This is a classic example of durability right from the get-go. So you guys didn't do a good job of vibrating this specimen. Last year, I made sure when I was helping the students, all our specimens were spot on because students were actually vibrating, and it's pretty clear to me that you guys didn't pay much attention. So at least it's a blessing in disguise. You can see what a bad beam looks like when it is not poured. Like this thing, as a structural engineer, you should never sign off on it if you see something like this. Yes, like it's bad right from all sides, literally, and it's very difficult to fix something like this. Like it's a recipe for disaster. The contractor will come and he will say, hey, I can fix this, I can put plaster on it, all that. Yeah, all bets are off here.
So what would you do? Just chip it all off and just repour it?
Well, that's the thing. Don't get yourself into a situation where you have to deal with this. What it means is that you should be there, or one of your representative, make sure that it gets done properly the first time. Any solution, of course, you have to come up with solutions. I don't think he's going to chip it and re-pour it. It's a trade-off, but no solution is perfect if the job is not done properly in the first place.
What would you recommend they do?
Well, don't sign off on this.
Okay, but you got to do something, right?
That's right. What you should do initially, once this gets done, then he'll propose a few solutions. Like this is terrible. I mean, I haven't seen concreting this bad, really. Like a contractor would know how to pour concrete, and I go to sites all the time.
We're starting to see cracks.
Oh, there we go.
So there's a bit of a change in deflection. Yeah, you can see a little
Yeah,
bit
so
there.
we'll talk about those later. Yes. So we'll start seeing some cracks here. It is in the right direction. Yeah. And we will study about these cracks on Friday. Because it's the shear design. We'll talk about it. These are classic, typical flexural cracks, and we'll talk about them in more detail.
You said this is force-based?
Sorry, this is displacement based. The test is displacement based. Yes, so we are controlling displacement essentially. Yes.
And what was the rate? You said 0.8 millimeters per minute for the first one?
The first one, yes. This one is higher than that because the first one was done to determine the models of rupture. So ASTM has a requirement what should be the rate. This is just to demonstrate you what a flexural failure looks like. So in the interest of time, we have just increased our rate of displacement. I think it's 3 times of what that was. We increased it 3 times, right? The rate of displacement for this.
3 millimeters per minute.
3 millimeters, yes. So the first one was, I think, less than a millimeter. It was 0.8 millimeters for 1 minute, and this one is 3 millimeters per minute. So there we go. Oh, shoot. So this is looking really nice. And we don't see any shear cracks per se for now. Yes, they'll be diagonal. Yeah. Sorry. Well, this is again. You have to keep in mind that this region is not high in shear. Okay, this region is high in flexural, and that's why anything between those two, those are flexural cracks. And so this is what I was talking about in the class, that as a structural engineer, you should design beams that fail in flexural, because you can see there's plenty of warning here. Like these are not minor cracks we're talking. These are significant cracks. These are not hairline cracks. So this should give plenty of warning to the residents that they should leave, correct? On the other hand, if this was a shear failure does not give you any warning. It just starts, and the next thing you know, it just fails. And if this, you'll see that if there is no shear failure, we won't be able to fail it completely. Fail it to the point where the beam loses its load carrying capacity. And that's what a good design looks like.
What are the drops in the graph? Is that when the cracks form?
Well, yeah, because I think now the loading is, sorry? Well, yes, that's right. So basically now we are way past the yielding is taking place. And that's where you see a drop in the load, and then the steel starts taking. So there is past your yield point, there is a lot of complex action happening between concrete and steel because the bond is not perfect anymore. When you will draw these, you'll see. Well, yeah, I think we are just. Where did we go last time? Is it dropping now?
Yeah, kind of. I mean, the steel is still holding it.
That's right. Yeah. Yeah, I think this is. Oh, there you go. Yeah, this looks pretty good. Okay, yeah, I think we are pretty much done here. So you can see that we are, it is still,
No, it's dropping there. It's going down, right? The max.
yeah, no, I'm looking at your channel, the sports I'm looking at it. Yeah. What was the maximum?
Goes back and forth.
So now you can see that shear crack is taking place right here. Yeah, yes. There we go. Yeah, this is a very nice failure. Yeah, I think we are. Yeah, yeah. Now you can stop. You can stop now. Yes. Beautiful. Beautiful.
Hey, Bilal, apparently for this last beam, the vibrator broke while they were using it.
Is that right?
That's why it's not really consolidated, yeah.
Well, to be honest, the other beams, they don't look that great as well. But this was the worst of all. Yes, I agree. Just give me 1 second. My parking is.
Do you know when the midterm marks will be posted?
They should be posted soon.
Like days?
Hoping by this Friday.
And is there a lab manual we can follow to write our report? And is there a rubric as well?
I will upload my last year's lecture on that, and I think that should give you a good idea of how to put together the report. Yeah.
And all the information got taken from the last lab, that measures from last lab as well as today's lab will be all posted, right?
Why do you need information from last year? Oh, last lab means yesterday's lab. Yes, yes, that's right. Yes, that will be. So you will have Excel files, and they will show the loading and the displacement and the time. And you just have to take those and put together the graphs. And yeah, and prepare your reports.
Okay, and today's information will all be posted.
Everything will be posted, yeah. Oh my God, that is terrible.
It's just the quarter inch.
I don't know if there is a proper bond between steel and concrete in this. Sorry. This is a little too,
Come this way a bit.
a little to that side.
more to that?
Yeah, just slightly. It's just that the concrete is not nicely poured here, and I worry that I don't want a premature failure.
You have last.
Just slightly, please. Thank you.
Good enough.
Yeah, that's good enough, I think. We'll see how it goes. Yeah, I worry that this could just snap.
It's Friday. Yeah.
Friday? Okay.
When can we expect midterm marks back?
Hopefully this Friday. Yeah.
Friday.
Yeah, hopefully Friday.
For the final, can we get a practice final?
Practice final?
Yeah.
Well, this midterm was a practice final, wasn't it?
No, that's a midterm. No.
Yeah, I think. We'll see how it goes, but yeah, final should be very similar to the midterm. Yeah, I hope so. Yeah, it should have given you guys a good flavor of what your final would look like. Yeah. Did you guys try to solve the midterm when you went home after the midterm, or you guys haven't given it a try? How many of you actually solved midterm after the midterm?
I didn't realize they could keep the sheets.
Yeah, I don't memorize the questions.
Oh, some of you did. So you guys haven't really.
I can share the copy of the questions.
I can post it on Brightspace. That shouldn't be a problem. But I'm curious to see how many of you actually looked at the midterm after the midterm to see. Huh?
How can we look at it if we don't have a midterm?
Well, you guys had midterm. We didn't ask you to
Yeah, we've never been able to keep midterms in any class.
You always have all papers.
That was not a requirement from my side. I didn't.
I had it. You didn't make it notes.
Typical. Yeah. Standard procedures. Kind of submit everything once you're done with it.
Well, not with my midterm. I mean, I was interested in your answers. Midterm was for you guys to keep.
How's the marking going?
It's getting there. Hopefully, TAs are marking, and it's not me, as I said. So we'll see how it goes. Yeah.
It would be helpful if you could post the midterm questions on Brightspace.
Oh, absolutely. I will do that. I didn't know that you guys haven't actually asked for the questions. If you don't have it, and if you guys want to prepare for the final, shouldn't you ask for them? Just out of curiosity?
In all our other classes,
We've never
we can't
been
do
able
it.
to.
We don't
Because
get
then
to
you
see
can
the
share it
questions
with the
ever.
next year, right?
Oh, I don't care. Sure, share it with the next year. The questions I ask are conceptual questions. So, oh, that's what I was worried about. That's exactly my worry was. Yes, that's what the worry was. Yes. Yeah. Yeah. So this is what happens with a poorly poured concrete beam. Yeah, I had my doubts right from the get-go. So I guess we just have to take some pictures and, oh, this was the last one, right? Or we have one more?
Well, you often learn more from the what doesn't work than what works.
That's right.
Definitely remember that one.
That's right. No, that's,
Yeah.
You didn't hit me though. We need a shield here.
yeah.
I should probably because the camera is not capturing everything.
Yeah.
So I should really temporarily.
I guess we can't. Is it possible to
Move that in.
move that in and just?
Can be public now.
Is it possible? Because the beam is still pretty in good shape, and we can still show our. And I'm sure it will fail just fine. Let's give it a try.
Probably it can be just.
Yeah.
So while this looks like it does have air and training agent, would you agree?
It should, right?
It looks like it.
See, now I have to put my other glasses on and give me a sec.
The label said no air and training agent, but all of them except the control had it, so
It's like it.
To be honest,
Lots
it's.
of little words.
Can you see that? I don't have good
Can you
eyes.
tell that
I see
versus
it.
the just
Well,
not being
just-
consolidated?
Well, that's the other thing. It's like if you put this right beside the other, and you should be able to tell that the surface. To be honest, this was poured.
You'd have to look at the
No,
far
no,
right
I
side,
don't
though.
think this has air and training agent. If you look at that one, this has lots of pores. I don't see this, and the other part is like there is no.
it's hard to tell if it's from the air and training agent or if it's just from
That's
the
right,
consolidation.
exactly. There are so many voids up there. But maybe we could actually.
Want to move both closer so it's symmetric, or
Yes,
leave
yes,
it,
yes.
yeah.
That would be because, to be honest,
Yeah,
you
yeah,
want
yeah.
to be further in. Yes.
Easy enough.
Otherwise, man, it's hard to tell, really. No? Excuse me? Just give me a second. how much even. You can't tell, can you? This is a control specimen. Excuse me, can I just step there and see what is going on here? Yeah. Can't really tell unless you have a magnifying glass. Last year when we did, we had enough air and training agent that you could literally see the difference between the two surfaces very clearly. I don't even know how much air and training agent they put in this time around. It was, TAs said that they would look after the lab this time. Not too stoked about it. Yes, that's what. Yes, that's what I'm gonna do. Can I just?
So you can measure the extra distance.
So this should be the same, right? Oh, this is now. Yeah, six and yeah,
That's from here to there. Yeah.
26.
Okay.
6. Okay, I'll just give me 1 second. Let me put it there.
Yeah.
I said 26, right?
Yeah, okay, well, I am. Actually, I guess you're practicing
Okay. Okay, guys. So for the revised span, it's 26 inches, and let's hope that this time we don't have a premature failure. Okay. So you can discard the earlier specimen results.
We changed them to, was it 5 millimeters?
5?
Instead of 3.
Okay.
We're a little faster.
Yes, it will go faster. Yes, and it's. Yeah. No, I don't think it's going to happen now. Don't worry. Yes. Yeah. No, I. That's why I was worried last time as well when you put it.
It's still 3 millimeters per minute.
5. It's 5 millimeters now.
Yeah, so the first one was 0.8 millimeters per minute. The second one was 3 millimeters per minute. This one we're doing 5 millimeters per minute, so I guess they want to get it a little faster. So, but I think for every other one, yeah, this one. Yeah, but
We are at 100? Yeah. 100 kilonewton, eh? Yeah, it's going to be a. Sorry?
No, well, you can wait a bit longer.
It always happens.
The other
You,
one was reverse side, more bending towards.
yes.
Maybe a little bit more.
Yeah, we stopped. We bent the other one at 150.
but it was twice as
Well, it was twice as,
well.
that's right. Yeah. So there we go. So you can see, guys, that there is a shear crack already appearing. The force right now is about 167 kilonewtons, which is way more than what the previous specimen took, like this one. So this is the failure you want to avoid, where you really don't know what's going on, and yes, it is. And this either will fail in shear or it should fail in concrete compression, essentially.
Okay, guys, drop it.
There we go. There you go. Now you see that the concrete failed before and that's exactly what a concrete controlled failure looks like. Yeah, you can stop now, I think. Okay. Yes, that's great. And the compression failure is more evident in the back, and you can see it on the screen there as well. There we go.
Yeah. You're like, I just discovered something amazing.
But it's funny, a table of metal. I recommend those samples.
Awesome.
I'm going to wrap up the recording
That's great.
here. So
That's right. Thank you.
Yeah. Hi, so I'm curious, so I just want to double check. So how can you figure out that is a concrete control?
Because the concrete failed before we saw significant cracks, flexural cracks, right? In there you can see the top surface is still pretty intact. However, your steel has yielded. That's why you see those vertical cracks. Those are typical flexural cracks.
And Louis, you kind of notice at the top, it's like material is pushing out, so it's in a compression mode. It's not like a crack form where it's in tension.
Okay, so guys, I think this is pretty much it. If you have any questions, you can ask. Otherwise, I'll see you on Friday. And if I have the test results by then, midterm results, I will post them. And I hope that you guys get good grades on the midterm. How many of you are expecting a 90% or above? 90%? 80%? 80? Okay, good.
It's pretty tough to focus during the midterm when you were talking the whole time.
That's right. So we'll take care of that. It's just that I take that feedback. You're right. Next time, if you don't understand anything, you just assume and you carry on. It's that simple, really. I am surprised that you guys didn't try the midterm, and I genuinely believe if you try it at home, you will see that the stuff that that was on the midterm was very basic. Like I didn't even ask most of the difficult stuff.
Yeah, honestly, I didn't find that the midterm itself was incredibly hard. It was just, I can't do two things at once. I can't listen to you lecture while I'm writing midterm.
I agree, and I confess that was, but I had to talk because most of you were.
You could have just said no.
That's right. Yeah, no, that's right. Like, I looked at it, and there was only one question where most of you were arguing about the formulas, and that was the last question probably, right? I effective, ICR. And I was worried that, I was surprised that you still have 6 questions. If let's say you don't know the formulas for the last one, put that aside. Focus on the 6 questions that you have.
Yeah.
You were arguing about the last question.
But the last question is like 5, 10 or 15 marks, so it's
The first one was 20. The second one was 20. The third one, fourth one. We're talking about 80% of the midterm that you guys just set aside and you guys were quarreling about. And I